Hello, my name is Kevin Wynn, and this is Lab 1 for the charge tapes. The purpose of the lab is to prepare two charge scotch tape and observe their interaction. We will also determine approximately how much excess charge is on one piece of charge tape. And the equations I used were the electric force equation, the electric field, and Newton's second law, the momentum principle. So my expectations on the lab, I expect the two charged U-tapes to repel each other since they are like charges. The U-tape will also be attracted to neutral objects because of polarization and dipole moment. And we're going to figure out if the U-tape is positively or negatively charged by rubbing a plastic pen against my hair, which will make it a negatively charged pen. And if the tape is attracted to the pen, that means the tape is positively charged. Or if the tape is repelled from the pen, it will mean that the tape is negatively charged. So from my observation, I did notice the two tapes repel each other. The U-tapes were also attracted to neutral objects. And the tape was also attracted to my negatively charged pen, showing that the U-tape was positively charged. And then we're going to interact the two U-tapes together to find the charge of a U-tape. So we're going to be focusing on the B tape that's floating because of tape A. And we know that the only forces interacting in the y direction is the gravitational force and the electric force. And we know that the tape B is not moving, and so according to Newton's second law, F equals dP over dt. dP is equal to 0, so the net force in the y direction is equal to 0. This means that the force of gravity and the electric force are going to equal each other, which is right there on my free body diagram. And to figure out the electrical force, we're going to first find out what the force of gravity is. And to do this, we're going to do mass times gravity. So first, we know that the tape is 1 grams per meter. So I found the length of the tape. And then I calculated the mass of the tape. And I just multiplied mass and gravity together. And that's going to equal 0.00196 Newton, which is also the same as the electrical force. Now that we have the electrical force, we can use the electric force equation and the electric field equation to solve for the charge of B. And we know that both charges of tape B and A are going to be the same, so we can simplify the equation together into QB squared. And the distance between the two tapes were 0.015 meters, so I just plugged in all the variables and solved for the charge of B. And that's going to end up with 7 times 10 to the negative 9 coulombs. Now we're going to find the deficiency number of electrons to atoms. To find the number of electrons, we're going to do the charge of the tape, divide that by the charge of an electron to get the number of electrons. Then we're going to find the area of the tape and the area of the atom. And then we're going to divide the area of the tape by the atom to find the amount of atoms on the tape. And now we have the number of electrons and number of atoms. We set that together as a ratio, which ends up being 1.15 times 10 to the negative 7 to 1, which shows that there's a ratio of less number of electrons than number of atoms, which makes sense, which is why the tape is positively charged and there's a deficiency. So our assumption, we assume that all the atoms were the same size to find the area. Both U-tapes were the same charge and magnitude. The tapes were also point charges, and there were uniform charge distribution throughout the tape. So now, what if the electrons and protons swap charges? They would still interact the same between the two tapes. They would still repel each other because of like charges, but however, the tape would be negatively charged, and there would be an electron excess instead of deficiency. Now, why is it important to handle the charged tapes as little as possible? Because the more that we touch it, the more electron transfer from our hand to the tape, making the tape neutral. And this is my code for the interaction of the two tapes. So I set up our constants right there, set up the position of tape A and B, where tape B is 0.015 meters above A. Both of them were positively charged. And then I found the electric field of A on B and the electric field of B on A. And I got the gravitational force by mass times gravity on both tapes, and this is my function of the electric field. And this is my model right there. So this is tape B and this is tape A. So you can see on B, the electric field and gravity cancel each other, and this is the A is the electric field is going down and gravity is down, and this is the tape that we are holding. And that's it. Thank you for listening to my lab.